Okay. It's finally on. So, this chapter is going to be on chemical equations and then types of reactions. So, the beginning of this chapter, we're going to learn how to balance equations. Remember doing that in physical science? Yeah? Okay. We're going to do the balancing, and then later on we'll look at types of reactions. So, indication that a chemical reaction occurred. It might be in a different order. Because I don't. Oh, maybe it did skip it. I don't know why. There. So a chemical reaction is a process in which one or more substances are changed into one or more different substances. So we have some reactants, which are on the left side of the equation, on the left side of the arrow. The arrow is called the yield sign. The reactants, and then there's products, which are on the right side of the arrow. So this is an example of a chemical equation. Ammonium dichromate yields, it's going to decompose, it's going to split up into different elements here. It decomposes into nitrogen, chromium 3 oxide, and water. But what you should notice is that the number of atoms on each side of each type of atom, so nitrogen, there's 2 nitrogens on the left and 2 nitrogens on the right. So the nitrogens are balanced. And same with every element. You have to go through and balance each element type. And some indications that we know a chemical reaction occurred. If in that reaction it releases heat and light, heat and or light, it would be a chemical reaction. It produces a gas. What would you see if it produced a gas if we mixed 2 liquids together and it produced a gas? What would you see? No? If you had 2 liquids and you mix them together and they produce a gas, what would you see inside the liquids? Or what if you put a solid piece of metal inside a liquid that had a chemical reaction that makes hydrogen gas? What would you get? Bubbles. See bubbles. Formation of precipitate. Precipitate is just one phase of matter that's produced in a different phase. So just like rain is precipitation that we're familiar with, but it's a liquid that forms within the gas of the atmosphere. In our case, we are mostly going to be dealing with solids that form within liquids. So you'll mix 2 liquids together, but it will form a solid that will settle down to the bottom, and it can be colored even. A change in color is also an indication of a chemical reaction. You might want to add that one. Change in color. So a chemical equation has to represent known facts. We have to know what is reacting together, and we have to know what is being produced. And you have to make sure you use the correct formula. So we may be given an equation in word format, meaning it spells out sodium chloride reacts with whatever. You have to be able to write those correct formulas. So you will probably need those ion sheets from last semester, because you're going to need to know how to write correct formulas. And then the law of conservation of mass must be satisfied, so the number of zinc atoms on the left must be equal to the zinc on the right. We can't lose any atoms there. Even if we produce a gas that would bubble out and escape, we're still going to put that into our products because we do produce it. You would take the mass of it. It's escaping. You aren't destroying mass. Whoa. There's some symbols. An S stands for solid, L for liquid, G for gas. Those are pretty self-explanatory. AQ, we will see this a lot, is an aqueous solution, meaning we'd have a solid that's dissolved in water. Like sodium chloride aqueous solution would be if you have table salt, you put it into water and it's dissolved, you'd have a salt solution, an aqueous solution. The right arrow means yields. So the yield sign should always be pointing towards the right, so your reactant should always be on the left, products on the right. If you write down the products first, you should probably just erase them and write them on the right. Okay, you can't just leave the products on the left. Then we can use a down arrow to show a precipitate or solid that's formed. Why do you think they use a down arrow? Well, our precipitate is a solid that forms in a liquid.
Because the gravity holds it down.
Well, if solid is in a liquid, where does the solid usually go?
To the bottom.
Usually sinks, yes. It goes down. Why do you think they use an up arrow for a gaseous product?
It's up.
Yes, bubbles usually go to the top, right? So they go up. So to balance equation, here are some steps you should go through. You need to make sure you write the formula equation with correct formulas. If you don't have the correct formulas, you probably are not going to get it to balance. So it's very important that you write the correct formulas. And then we're going to balance the different types of atoms one at a time. A lot of times it's easiest to balance the hydrogen and oxygen last, so balance everything except for those. And then just always recheck, make sure that you have all that right. An important note, do not change the subscripts. So we are going to be able to add coefficients, which are big numbers out in front of the formula. That the coefficient carries through the whole formula, unlike subscripts, which just carry to the element that's right before it. We cannot change subscripts. If we change the subscript, we're changing the whole chemical formula, and that's not correct anymore. So we write coefficients. And these coefficients indicate relative but not absolute amounts of reactants and products, meaning they're kind of like ratios. In your balanced equation, it may take one, the coefficient might be 1 for one element or one compound and a 2 for the other compound. But we could have, in reality, when we actually do it, we could have 2 of the first element, but then we would need 4 of the second. It's still a 2-to-1 ratio, but they're showing relative amounts. That's what that means. Next chapter, we're going to be able to do some calculations using the coefficients because they are ratios of the moles. So like 1 mole of one compound requires 2 moles of another compound to react. So we're going to use those as mole ratios and then convert them back into masses. And the reverse reaction has the same relative amounts and substances as the forward reaction. So reverse reaction would be going from the right to the left. And usually that will only occur if you add energy to that substance or that reaction. So we are going to write balanced equations for these problems. It says indicate symbols for physical states when indicated, so we need to use those S, L's, and G's and AQ's to show states. So hydrogen peroxide in aqueous solution decomposes to produce oxygen and water. So what is our reactant? Well, what's the name of it? Hydrogen peroxide is our reactant. So we need to figure out what the formula for hydrogen peroxide is. Yes, because hydrogen is H+. What's peroxide? You look on your chart, it's O2 with the 2- charge. So our charges cancel. We need 2 hydrogens to balance that out. So it's just H2O2. and it tells us it's aqueous. Let's put our AQ. So it decomposes and yields what? Okay, oxygen. What is oxygen's formula? O2, right? It's one of those diatomic molecules. You need to know the diatomic molecules. Do you remember those 7? Let's look at them again. There are 7 of them. And if you look at the periodic table and start at element number 7, which is nitrogen, start there, nitrogen, and then draw 7. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And then hydrogen is also one that's just not in that group. Or you can remember the saying, starting at iodine and going up, I brought clay from, and then going to the left, our new, and then hydrogen is house. There's 2 different ways you can remember that. But those are all diatomic, meaning you have to use, it'd be O2, N2, F2. When they're by themselves in elemental form, then they would be diatomic. So we produce oxygen, which is a gas, plus what? Which is what? H2O. And water is a liquid. Okay, so there's our equation. Is it balanced, though? Let's check. How many hydrogens do we have on the left? And how many oxygens? And how many hydrogens on the right? And how many oxygens? Ooh. So it's not balanced, is it? Oxygens are not balanced. Now, any number that we put out here, we're always going to have an even number. So is there a way we can get this side to be even? Where? The H2O. Okay, so if I put a 2, so we have to add coefficients. We can't change subscripts, so I put a coefficient out here. Now that changes our hydrogens also to 4. But now how many oxygens do I have? 4 as well. Is there a way we can make both of these be 4? Put a 2 here. So now we have 4 and 4. Yes. Now it's balanced. Now you may get to a point where maybe you would have balanced it. I'll put it in red here. Maybe I would have put a 4 here, a 2 here, and a 4 here. It's still balanced because we would have 8 and 8 and 8 and 8. So it's balanced, right? But we always want to have our coefficients in a reduced state as far as we can. So we could divide all 3 of these by 2, and we would get our 2. This would be like a 1 and a 2. So if you do see that all your coefficients can be reduced, do reduce them. Okay, what's the next one? Next one says, solid copper metal reacts with aqueous silver nitrate to produce solid silver metal and aqueous copper 2 nitrate. So what are our reactants? Copper and silver nitrate. So what's our formula for copper? Do we need 2? Well, you're thinking of charges. We do not need the 2 down here because it's not one of our 7 atoms. Only the 7 diatomic atoms need the 2, so it's just Cu. And where it's solid, so we'll put a little S behind it. Okay, and then it's adding silver nitrate. Let's draw the formula up here. Silver is what? Ag with what charge? And what's nitrate? What charge? So what's our formula? There we go. And it says it's aqueous, right? Let's put a little AQ. Okay, so what does that yield? Silver metal and copper nitrate. Copper 2 nitrate. So what's silver metal? What's our formula? Is it a diatomic atom? No, it's not. So we just leave it as Ag, solid. So copper 2 nitrate. So copper is Cu. What charge does it have? Since it tells us it's copper 2, it's 2 plus. And then we know NO3 is a -1. So what's our formula? Good. So I would agree that is the correct formula. But is it balanced? Let's check. How many coppers on the left? Just 1. How many silvers? Okay, and now nitrate, since we have NO3 on both sides, we can balance nitrate as a whole. You don't have to split the nitrogen and oxygen. So that's just a trick you can use to make it a little easier. But whenever you have a polyatomic ion, if it is the same on both sides, you can balance it as a whole. So how many nitrate ions do we have? We just have 1 NO3. So on this side, how many coppers do we have? How many silver? And how many nitrates? We have 2 this time. It's not balanced. How would we balance this? A 2 here. Okay. If I do that, I've changed this to a 2 and this to a 4. One where? Right here? A 2? Put a 2 on each of them? I have to put a 4 here? So that changes this to 4 and this to 4. Put a 2 in front of copper. Okay. Which makes this a 4. So now we're balanced, but now look at our coefficients. What can we do? Divide everything by 2. So it would be a 1, 2, a 2, and a 1. So if we would look at this, I'm going to erase this here quick. If we look here, we have 2 nitrates here. And that's the only thing that's unbalanced. If we were to add a 2 right out here originally to give us 2 nitrates, our coppers are each 1 still, but now we have 2 silvers. If we just put a 2 here, we'd get 2 silvers. So when we have this written out on the bottom, try to get, like the one that's not balanced, balance that first. That should make it a little simpler. So now there would be 1, 2, 2, 1, 2, 2. Okay, the next one says solid zinc metal reacts with aqueous copper 1 nitrate to produce solid copper metal and aqueous zinc sulfate. So what's our reactants? Solid zinc and copper 1 sulfate. So copper 1 has a +1 charge, right? Tells us that. What is sulfate? SO4, and what charge? So what's going to be our formula? And it tells us it's aqueous. And what do we produce? Copper metal plus zinc sulfate. So zinc has what charge? 2+. And sulfate, we already said, is SO4 2-. So what's our formula? ZnSO4. We just need one of each. Balance charges, and that's aqueous. So now we have to check if it's balanced. So zinc is 1. How many coppers? How many sulfates? Sulfate is on both sides, so we can balance it as a whole. 1. So how many zincs on the right? And how many coppers? And how many sulfates? 1. So how could we balance that? Put a 2 right here. And that should be it. Yep. Questions so far? Okay, I want, let's see, let's have Ashley's row. You guys are going to do A. Cole's row, you guys are going to do B. You guys are going to do C. You're going to do A. Derek, B, C, A, and B. B. Okay, kind of work on it. You can discuss it with your group. Yeah. Does anyone else need an ion chart? Yeah, I will. So when you and your group think you have your answer, I'll let you guys write it up here.
I don't even know how to get the formula.
I don't either. Like nitrogen dioxide? Like what is that?
I know.
Nitrogen and di means what?
2.
So how many oxygens do you have?
Look, this is exactly what I put down.
Yep, that's right. NO2. You have B.
The diaphragm just means that there's a 2 after like the oxygen.
Mm-hmm.
It doesn't change the charge or whatever.
Nope, don't have to do with anything with the charges.
This whole chapter is just gonna. This is the same chapter. CA2OH. What that is.
You just have yours? 6 and 6, 2. Yeah, I think so. So like, here, let me. Here's gonna be A. Just write your balanced equation up.
Got it yet, Easton?
It says this reacts with water, so that's water.
Mm-hmm.
But how am I supposed to make that?
Okay,
over here with
now
no
calcium,
water on the second side?
solid calcium, do you have to use the 2? Is it diatomic?
It says 2 right here.
That's its charge, it's not, but it doesn't have, you wouldn't put a 2 there.
We're putting the 2's down over here.
Not when it's just a solid metal. Like not right there or right there when they're just solid metals. When you make a compound on the product side, yes, you'll have to look at that. Because calcium's a 2+, hydroxide's a -1, so you remember how many hydroxides do you need to balance out the 2+. So you, instead of having a 2 there, you're going to put parentheses around your hydroxide and put a 2 on the outside of that.
That
Subscript, yeah. Mhm.
subscript.
Mm-hmm. And then don't put a 2 on after the calcium.
What do I do with this H over here?
Now hydrogen is diatomic. It's one of those 7, so then yes. And get rid of that too. There you go. Now balance it.
Oh, there's balance.
Is it?
Water, that's what I need.
I was wondering if I could come in and give period and ask you questions. I was in here for 3 days and I don't know what I'm going to do on this because I don't know anything at all.
Have you watched Angel yet? Okay, I think that would help. Do you have, is 5th your study hall? Is 5th your study hall?
Or no, sorry, 3rd.
Do you want to pass to the library to make sure you get there so that you can, and then you can come in 5th, like during channel 1. Okay. See if you can come over during just channel 1. And then if you have questions after watching it, that would probably be good. That way you can make sure you get there. 3 and 3. 2 and 2. 6, 7. On B is NO3 at the end, correct? What is the... Because your oxygens are not balanced like this.
NO3. I know.
Is it nitrogen monoxide?
It's just nitrogen monoxide, yeah.
Okay, so
So, Nikki,
Come here, Valley.
scribble out that two.
on the very, very end of B.
Valley.
That very end on the far right, that last 3. Scribble that out. Because it should be monoxide.
Is that really a 3?
No, because you get. Oh, wait,
Sorry, Kibo.
oh, yeah, death,
What happened?
actually. It's still wrong.
Valley. Or Reese. Come on, get this real quick.
Is that still wrong?
Well, because I added 3 and 3 instead of multiplying it. So it'd be 9 and then 10 and on the other side.
You just have 7, huh?
Okay.
Yes?
It wouldn't be a 2.
Did I do that right?
Oh, the first one, NO, it should be NO2, shouldn't it be? Isn't it nitrogen dioxide, not nitrogen trioxide?
Hey, that's fine.
Because now you'll have 6, 7, and then you'll have 6, 7, yes.
Pretty sure I did it right.
NO2 reacts with water.
Where's the 2 values?
Yeah, those are your right formulas. You don't need to put those 2 minuses there, though. But that's the right formula.
Did I do that right?
So you have 1, 2, 3, and 2. Yep. 1, 2, 4. Yeah.
So how do you balance them out?
What was wrong? Why was I doing it?
So then,
You told me I was wrong.
let's see, what could you balance first? If you balance the hydrogen first.
What do I have to balance? I have to get
You have 2 here and you only have 1 here, so put a 2 there.
So is it like multiplying by whatever the number
Mhm.
is?
So now you have 2 hydrogens. Let's change all your, so you have 2 hydrogens now.
I have to get
You have 3 nitrogens. Because you have 2 here plus 1. So now you have 3 nitrogens.
on over here.
Uh-huh. And now you have 6 oxygens plus 1, so now you have 7 oxygens. Okay, so now let's look at nitrogen. You need 3 of them, so put a 3 out here.
So that's
So now you have 3 nitrogens,
and then
and now you have
9
3
oxygen.
times 2 is 6 plus 1, 7 oxygens.
And then-
Tomorrow. Yeah, make sure you get these written down. I think they're all correct. Let me just 4. Yep, make sure you have those written down.
Sure. Yeah. Are you going to the library today? And yeah. All right.
Yes.